All right, we're live now. We're recording. So, okay. Sketch at least one cycle of this, blah, blah, blah. So we saw yesterday that negative values of B are not really desirable. So for odd functions like sine, once we factor out the B value, if it's negative, we bring it up front, okay? And it turns the sign of whatever A is into the opposite, okay? Having negative A values are fine because the way we graph that by the Sahala-Challa method is we just flip the highs and lows. Much easier to work with the negative A value than a B value. So for odd functions, we bring it out front. Sahala then could then turn into negative Salaha. And for cosine, if we have a negative out front, it becomes negative Cla Hal. I don't know what happened to the L that was there. Negative Cla Hal, right? He's like the derpiest of all the superheroes, right? You got Sahala, Chala, Salaha, and negative Cla Hal, right? So what happens if we have a cosine with a negative B value? Well, that's what this one is about. All right. So let's go ahead and sketch at least one cycle of this. Step one is the same. Put it in standard transformation form. And this one has a couple of things that we need to do, right? We need to bring the 2 in the front to the back. And we first need to bring the X term inside to the front. So I'm not going to do this in 2 steps or 1 step. I'll do it in 2 steps. So I'm going to have a negative 4 cosine. There's the inside. And I'll put the +2 at the back, right? And on the inside, my first step is just to put the negative 3x term first, okay? If I try to factor out the negative 3 while I'm flipping it, I'll make a mistake. Y'all know that. So I try to avoid that. All right, so now inside, I can't just contend with the negative right now. If it's not in standard transformation form, if B is not a factor, you can't bring it out front or get rid of it, whatever the case may be. But once you factor it out on the inside, and you'll need these extra set of parentheses, then you can. All right, so when I factor a negative 3 out of a negative 3x, of course, I get x. What do I get when I factor a negative 3 out of a negative pi? Positive pi thirds, right? Because factoring out is the same as dividing out. And negative pi divided by negative 3 is positive pi thirds. Notice the extra set of parentheses, right? Open, or open, close, right? There we go. So make sure you have them. If you're doing this on a test or something, or quiz, and you miss that closed one right there, now that +2 is technically inside, and you're going to lose points. So bless you. Make sure you have both sets there. Okay, so that's standard bless you transformation form. Bless you. I'm trying to teach here. Excuse me. Yeah, it's all right. I don't know why you just became allergic to math all of a sudden, but anyway. Your Claritin, right. You can. Nothing. I won't make any bad jokes. Anymore, right? Oh, okay. Oh, this is a comfy seat. All right. So, hey, look, everybody. I got a negative B value, right? That's a y-axis reflection, but I don't want to have to contend with it when I graph it. So because I have a cosine as my function off to the side, cosine of x, is cosine of x even or odd? It's an even function, right? It has y-axis symmetry. So here's the consequence, right? Negative inputs give you the same output as positive inputs. Negative and positive inputs give you the same y value due to the symmetry. So instead of bringing it out front, we do what we said yesterday. We forget about it. Forget about it. And I did look it up last night. That is the correct spelling. Forget about it. You could just drop it, right? Like if you were trying to find what negative 3 squared was, you're like, x squared is an even function. I'm just going to forget about the negative. And do we get the same answer? Yeah, because 9 equals 9. Yeah. So that's why we can forget about it. Cosine is even, so we drop it. So it stays negative 4 out front. And now we have a positive 3, x plus pi thirds, close, plus 12. Close plus 12, I said, which I meant 2, right? Why did I say 12 when there's a 2 there? I don't know. I know why. Because when I said close, close, I was thinking of a joke. I was thinking of like, yeah, that describes my wife's closet. But anyway, I shouldn't have said that out loud. I should have just been reading the question and said +2. Close, close. Right? There's like 3 closets full of nothing to wear. Actually, my wife, if she listens to this, she never will. Unless she goes behind my back to learn math. I don't know. She's pretty good at math herself. Yeah. She'll tell you that I'm the clothes hound in the house. I'm the one that has. I could wear a different shirt every day for like 5 years and not wear the same shirt. Yeah, it's just, oh well. Close. All right, let's go off to the side and do our A, B, C, D, P, and R. A, B, those get absolute value. C, D, P for period, and R for range, right? And I'm not going to be too picky if you put equal signs or colons over here, right? Doesn't really matter. It's just for your benefit. So the amplitude is what? It's 4, right? But because there is a negative there, I'm going to put a note to myself to flip the highs and lows. It's an easy thing to contend with a negative A. Negative B, not so much. Speaking of B, the absolute value B is 3. And what's the interpretation of that? It's going to be a horizontal compression by a factor of 3, which means we're going to see 3 cycles in 2 pi. Where we previously saw just 1, since we compressed by a factor of 3, we're now going to see 3 complete cycles. That's going to make the period what there? Bigger or smaller? Smaller, 3 times smaller, right? So once you find your B value, it's natural to come down here to the period and do 2 pi over that number and simplify. Well, there it is, 2 pi thirds, right? From 0 to 1, 2 pi thirds, you see your first cycle. From 2 pi thirds to 4 pi thirds, you see your second cycle. And then from 4 pi thirds to 6 pi thirds, you see your motorcycle, third cycle. Tricycle, bicycle. All right, now for C, is it left or right pi thirds? Left pi thirds. And then your D value is up 2, right? Which, if you want, you can also say then that your sinusoidal axis, your SA, is at y equals 2. Because remember, that's your D value. Whatever your D value is, whether it's positive or negative, you set it equal to y, that's your new x-axis, which we call the sinusoidal axis. And now for the range, remember how to find the range? Your low point is sinusoidal axis minus A. So that's 2 minus 4, which is -2. And then your high point is sinusoidal axis plus A. So that's 2 plus 4, which is 6, right? D minus absolute value of A for the low point, D plus absolute value of A for the high point. All right. Now we're ready to sketch that graph. So there's a y-axis, looks good. And then most of my graph lives above the x-axis. So I'll draw my x-axis, not quite in the middle. I'll put it somewhere over there. All right, let's go ahead and set up the vertical axis first because it's the easier of the two. -2 to 6. So you could say 1, 2. Okay, here's -2, and then 1, 2, 3. 4, 5, 6. Try to make those the same. Bless you. Bless you. All right. And now you can find the midpoint. Like if you don't know what the D value is, but you know the high and low, remember the sinusoidal axis is right in the emitter of the high and low. How do you find the average of 2 numbers? Or how do you find the midpoint of 2 numbers? Sorry, I gave it away. Find the average. Yeah. What's 6 plus -2? 4. What's half of 4? 2. So that should be your sinusoidal axis, and it is. So I'll draw a little sinusoidal axis in there. So that's your new x-axis, essentially. I'll even label it as y equals 2. There you go. And now the fun one, the x-axis. Do we have a phase shift? We do. So this is where we want to make a rough draft axis. I don't want to call it sacrificial. That may trigger some people. Here's 0. And then we come out here to the length of one cycle, which is 2 pi thirds, right? Thirds. That's the period. All right. Half of 2 pi thirds is 1 pi thirds. And then half of 1 pi thirds is 1 pi sixth. That's your most important number on the entire x-axis, because every single critical value is pi sixth away from every other critical value. X is high, X is low, X is high, X is low, even after a shift, right? All right. So let's go ahead and do this. If you want to label this one, what would that be now? 1 pi 6, 2 pi 6, that would be 3 pi 6, which is the same as what? 1 pi halves. Yeah, and then 4 pi 6, which is 2 pi thirds. So we simplify as we go. Now for your sacrificial x-axis, you do want to also give yourself one negative value. So the same distance away over here would be negative pi 6. It's helpful to include that. All right, now here's what we're going to do. We're picking the graph up. That's where the critical values are before the shift. We're picking it up and we'll move everything left pi thirds. Left pi thirds. Oh man, where is left pi thirds going to be? Well, pi thirds is a critical value, right? So look at this. If I have my negative, if I put another critical value over here, it would be negative 2 pi 6 or negative 1 pi thirds, right? So notice we're still going to get to use the same tracks, but instead of picking it up and moving it over one critical value, we're actually picking it up and moving it over two critical values, okay? So the good news is we don't have to make new marks. These values that we have numbered are going to be the values that we use, okay? So now I can go ahead and make my marks over here. I'm going to need to include two values. Now, as soon as you put down your first mark on the x-axis, since 0 is also a critical value, this distance right here between those, that's what you need to try to preserve, okay? So, and you can just eyeball it. So for me, I'm going to put my other one right there. That's my negative pi thirds. That's my horizontal shift left. And that's where I'm going to draw now my new vertical axis. All right, so that's your new y-axis. So you can see right here, negative pi thirds comma 2, that's like your new origin. Now I'm just going to add more values on the right-hand side, and I'm going to keep them about the same distance away from the previous one. Right, and that's enough. If you have a longer x-axis, you know, you don't have to keep adding them there. So that's enough. Now we'll label them, right? So if this is 0, this is 1 pi 6. This would be negative 1 pi 6. I do want to see a mark on every x-axis. And now you can just keep counting by 1 pi 6, right? The next one would be 2 pi 6, which simplifies to pi thirds. 3 pi 6 is pi halves. 4 pi 6 is 2 pi thirds. 5 pi 6 does not simplify. 6 pi 6 is pi. The next one would be 7 pi 6, so on, so forth, et cetera, ad infinitum, forever and ever. Amen. Okay. We've set the table. Your x-axis is set up, your y-axis is set up. Can't eat yet, got to put food on the plates. Plates are on the table, got to put the food on the plates. What do I mean by that? That's a really good question. I don't really even know where these analogies are supposed to go sometimes. You wanted to eat the plate, then your food's already on the table, right? My strange addiction, right? I eat plates. Let's come back to our function right here. Whoa, whoa, big red arrow. That's like wow. That's, yeah, I was thinking, I was trying to think of a Clifford the Big Red Dog joke, but anyway. This is a cosine, which is normally chala, but it has a negative in front, right? So let's think about it. What? Positive chala now becomes negative cosine. The highs become lows, the lows becomes highs, and we have negative klahal, right? Yeah. So there you go. So the C is for cosine. Our first critical value is going to be where? Low. Instead of high, it's low. So we come to our new origin, and we are going to put now a dot at the low point, which is right here. Now for cosine, it's easy. You start at a high point for positive, you start at a low point for negative. There's only one place to go from up and only one place to go from down. Remember yesterday for sine, though, we have to be careful because when we start on the axis, we need to know, are we going up for positive sine or going down for negative sine? Negative is always either down or going down. Positive is always either high or going high. I don't want to say getting high, but going high, right? You can get high on life or math or just, good alpine air, climbing a mountain, right? Rocky Mountain High, Colorado, John Denver. So where would the next critical value be? It would be on the axis. We got it all figured out. So this is putting red meat on our plate, or, red Jello cubes if you don't eat meat. Red Jello cubes. Reminds me of when I was in the hospital. All right. Let's eat, right? To eat, we just connect the dots with curves. Don't make them, I forgot something. Look, as I'm connecting my dots, it looks a little funny around the origin. What did I do? I forgetted it a dot. I didn't put one at 0. Oh, that's easy to do. I was like trying to put food on the plate, and I missed a plate. I didn't give somebody the food that they deserved. So the next one would be at 0, which is high, then axis, then low. And that's why it's so important to have your y-axis scaled to itself and your x-axis scaled to itself. They don't have to match each other on the scale, but they have to match with themselves. Because when you sketch your graph, it should look symmetrical, okay? Everything rises and falls the same way because we're just rotating around the unit circle nice and smoothly, okay? There you go. And then you go to your last point, whatever it is, and you extend it a little bit past and put an arrow. So that looks symmetrical, okay? That looks good. Now, once we have all that done, then it's easy to do what are going to do next, which is let's write an equation in terms of the 3 others. What I mean by the 3 others, well, you can always write 4 equations. One in terms of positive sine, one in terms of negative sine, one in terms of positive cosine, one in terms of negative cosine. We already started a negative cosine, and we started at a low point. So this is a negative cosine. If we want to write another negative cosine, all we'd have to do is find another low point. Do we see another low point? Yeah, there's one at pi thirds. How far apart are negative pi thirds and positive pi thirds from each other? No. Shouldn't they be one cycle away? That's the wavelength, 2 pi thirds. That's the period. There's also another low point at pi, which would be another negative cosine. How far apart is 1 pi thirds from pi? 2 pi thirds, which is also known as the period, right? Those are coterminal angles for this new graph that's 3 times narrower, all right? So you could do that if you want, but I'm going to go ahead and do the other 4. So let's give them different names if you want. We don't have to call them all F. Let's call one of them, what? Someone give me a name. Rob? Okay, I heard Rob. I don't know if even that's what you said, but from over here, it sounded like Rob. So Rob of X. Rob of X. We're going to do positive 4 instead of negative 4. Cosine of parentheses 3, parentheses X, leave it blank, close, plus 2. Again, the only thing that's going to change when you decide on one of those 4 is the phase shift. They're all just out of phase with each other. So what am I going to be looking for on the graph if I want to write a positive cosine? Where does positive cosine start? At a high point. Hi, Brady. Hi, everybody. Do y'all see a high point? I see one at 0. I also see one at 2 pi thirds. Yeah, you could do minus 2 pi thirds if you want. That would be fine. Or, man, if I use 0, I wouldn't even need to put x minus 0, would I? Because what's x minus 0? just X. So that would be probably the easiest one to use because I wouldn't really even need a phase shift. I make the equation look a little bit nicer. See that? Yeah. And you don't always get that luxury, but in this case, since 0 is still a critical value, we can. All right. So we actually have 2 for positive cosine. Let's go ahead and do, what's another name? Bob. Let's do Bob instead of Rob, right? So Bob of X, let's do cosine. Do you want to do positive cosine or negative? Let's do positive sine. Let's do positive sine. So what's it going to look like? Well, it's going to be positive 4, but now it's going to be sine instead of cosine. 3 is still B, but now it's X plus or minus something, something, plus 2 is still there. So again, the only thing that's going to change is the phase shift. Now, what am I looking for a positive sign? High. Very good. I need to be on axis going high. Axis going high. Where am I on an axis going high? At pi halves or at negative pi 6. Now, if I want to do negative pi 6, remember it's the opposite, so it would be plus pi 6. Or you can have x minus, I'm not going to rewrite the whole thing, or x minus pi halves for the inside. And then let's see, we'll do one more. So we got Bob, Rob. Let's do Bobbert, which is another name for Robert. Bobbert of X. It would be negative 4, right? That's the last one we need. We need negative 4 sine, parentheses, B is still 3. It's still X plus or minus something, something. It's still plus 2. And now all we have to do is look for the right spot. What are we looking for a negative sign? Well, it still starts on the axis, but now when the highs and lows flip.
So it's pi 6, pi half.
Right, we need to be on an axis going down. So here is negative sign here or negative sign there. I'll just choose pi 6. It's positive pi 6 in the graph, so it's minus pi 6 in the equation. Okay. There you go. And we can keep doing this, right? If you extend the graph out further and further, you can keep doing it. And all of those starting values that are for the same function, they're just multiples of the period away from each other. All right. How's that for a day's work? All right. I'm trying to get y'all caught up because of what happened. Yeah. Tomorrow we're probably going to skip example. Let's see. We're going to do only one of these tomorrow. I'll leave it to you to watch the video if you want of the other one. But what's going to happen on 11 and 12 is when we do our phase shift, one's cosine, one's sine. So it's really similar. It's just extra practice. We're going to have a phase shift that doesn't land in the same marks. In other words, we're going to have to make fresh ruts or fresh critical value marks. And that's where the sacrificial or the rough draft axis becomes increasingly important. Okay, so we'll do that tomorrow. And then we'll finish with example 13, where we're going backwards, which is, this should be easy because what we're doing now by already writing equations, once we create our graph, all we're going to have to do is, given the graphs here, we might have to fill in some details. Okay. But when we make our graph is already perfectly detailed. We have every critical value and only every critical value labeled, high point, low point, and sinusoidal axis. Okay. Any questions? We'll stop there for today. Tomorrow we're doing 10 in how much time? 6, right? 10 in 6. And if you're still struggling on how to do that, come see me in the morning before school. I'll be here. Tomorrow is already Friday day. Yay. Hey. All right. Bye, everybody. Hi, Brady. Hi, axis. Hi, axis low. Axis high. Axis low axis. Hi. Hi, axis low axis. Hi.